Hi, welcome to Manish IT. This is Manish. Today I am going to discuss about queue. So, what is queue? Before definition of queue, we have to understand it. That means how it's working. Let us see this picture. There are total five members. One member who is sitting at counter, that is a library counter, where any member can go and pay accordingly to their purchasing of a stationery product. So here we can observe that rest of four members are in a line, and one members who are nearest to the library counter, only she can only pay at the time others are waiting for their turn. So here we can say this is maintaining the line. These all peoples are maintaining the line. So that is nothing but that is queue. So same thing is happens in bank also. When you go to bank, then there is also a line for the respective work. That line is queue. Who are nearest to the counter, then those people will get first service. Similarly, in ATM, and one another most common example of when you are going to railway station at a reservation counter, so they are also maintaining a line, and the who members will go first at the counter, then that members only getting service first. So these all are about a queue. These all are related to queue. So definitely you understand about queue. Now, as we know, every function having their own property. So then similarly, it's a queue also having their own property. So first property is like a queue is a linear data structure due to sequential arrangement of element. Next, a queue is a first in first out, that is FIFO data structure, where the element that is added first will be deleted first. And next one, it is collection similar type data, and that is homogeneous element. So next, total number of elements in queue, that is equal to rear equal to front plus rear, that is equal to rear minus front plus 1. So here we observe on some operation of queue. So first one is NQ, second one is DQ, and third one is front, fourth one is rear, and fifth one is traverse. So front and rear always at the beginning of queue, it is pointing to 0th location. So see NQ, what is NQ and what is DQ. NQ is nothing but it is insertion. Addition of any element in queue is called insertion or NQ, which is done at rear side of queue. So DQ or deletion, removing of any element from queue is called deletion or DQ, which is done at the front position. So application of queue. So in real life example, waiting in line, waiting on hold for technical support, and also application of related to computer science, round robin scheduling and rob scheduling, and also third one is keyboard buffer. So question is that how to implement it by programmatically. So answer, it is very easy to implement by programmatically. Let us see one by one. So we are here we are declaring we are first defining one function, that name is void NQ. NQ is a function name and it's nothing return to value, so that's why it's void type. Data type is void NQ, and it's having no parameter. So also we have to check our conditions. So like if our in the starting time, we have to mention our size of queue. So suppose here we are mentioning our size of queue is 5. So here whenever rear is pointing to maximum rear is when rear is having value is 5, and that, our maximum size is also 5. So when rear and maximum is equal to, then print simply like queue is overflow. Otherwise it's in this situation there is rear is pointing to its 0th location. So here rear value is 0. So if condition is fail, so it is going to else part. So else parts having integer number type variable, and one we are giving a message to user, enter your number. So after scanning that number from user, that number is stored in queue. So queue here, suppose uh, once minute, suppose the queue is that number is stored in queue. So see, suppose user has entered 10, so like 10 is entered, then our rear is incremented by 1. So after incremented, it is pointing to second location, that is indexing number 1. So once again user want to enter some value, so that suppose user entered 20, so our after increment, every time all these conditions are checked by compiler. So enter that value, and rear once again rear incremented, and it's pointed to 2. Indexing number is 2, and location is third. So once again user want to enter some value, that is 30, so after increment rear is pointing to fourth location. So once again he want to user want to add on one another element, that is 40, so it's once again after increment of rear, it's pointing to fifth location. So once again user want to enter 50, so he can do that is entered, and rear after increment rear position pointing to at sixth, indexing number 5, and location is 6. So now once again user want to enter some value. So when enter some value, then he called enqueue function. Then every time after before entering this element, every time our compiler is starting from beginning. So here once again whenever user want to adding some insertion, want to insert some element inside this queue, so once again it is executed from if part, and here condition checking like rear equal to max or not. So rear value is 5, our size queue size is 5, so both are equal, condition satisfied, it's executed, queue is overflow, and simply come out from program. So it giving message, so we understood our queue is having no enough space. So now this is the insertion process of queue, and now we saw like deletion process, how to dequeue. So deletion is nothing but dequeue, so it's having also no any return type, and no any parameter. So once again we have to check our condition, if front is equal to rear, that is if in this condition front is 0 and rear is 5. So if rear is pointing to 0, it means it is underflow. So here is nothing here condition is like front is pointing to 0 and rear is 5, so 0 equals to 5, that is condition is fail. So it is simply come out from if part and executed else part. So here by mistake it's capital I, so please correct that, and write it is a small I. So here I have declared one variable I integer type, and simply printing like percentage d is removed. So percentage d is like for it is a format specifier, and it is message whatever is removed. So here q front, because of deletion is always from front position, so q front always, front is always fixed at 0, so we simply return here q front. So q front whatever element are there, that is deleted first, and all these elements shifted towards 0th location. So how, see how can it happens. So one whenever it is deleted, so we have to like insert 20 here, 30 here, and 40 here. That means we have to shift all these elements towards 0th location. So how it can be possible. So see 20 is entered, so after shifting all these elements, see it's looking like this. So after shifting in our program, we can see rear is decremented, so rear position is decremented by 1, so it's pointing to fourth position. So see this, it's pointing start pointing to fourth. So now once again user want to remove this 20, and so then once again a user calling dequeue function. So it's once again check because of how many times that function is calling, that many times our function executed from beginning. So once again user call like user want to remove this 20 from our queue. So once again it is executed from beginning. So once again it is checking their condition like front is equals to rear or not. So here if condition is failed because of front is 0 and rear is 4, so else part executed, and once again it is 20 is removed, and we these all elements are shifted towards zeroth location. So we have to like this, all these elements are shifted. So see how it's looking like this. So after shifting all these elements, see like this, then we have to decrement our rear position. So after decremented rear position, it is start pointing to fourth location, that is indexing number 3. So now once again user calling like a dequeue function, and user want to delete this 30 from our queue. So after calling that dequeue function, 30 is removed, and here shifting of all element, then how it's looking like. See, after shifting, then once again rear is decremented, and it's start pointing to third location, that is second indexing. And once again user calling like a dequeue function, then that means user want to delete this 40 element from our queue. So after deleted it, it start point like 50 is stored here, and our rear is decremented by 1, and it start pointing to second location, that is first indexing. So now again user called dequeue function, and I want to remove this 50. So how it's so whenever dequeue function, then condition checked condition, if condition is failed, then else part is executed and 50 is removed, and simply rear is decremented by 1. So see, rear is once again pointed to front. Once again user call like dequeue function. So what's happened once again when so I already told you how many times you are calling inside your function, this dequeue function, that many times it is started from beginning. So once again dequeue function is called, then it is starts from beginning. So once again it check their condition like front equals to rear or not. So front is 0, rear is also 0. So this condition is satisfied. So that means it is simply printing like q is underflow. So after printing this statement, our program is exist from this dequeue function, and it's not going to else part. So once these all are things about our insertion and deletion. So now we have to see like traverse, how to traversing in a queue. So see this in the suppose we in our queue having some elements 10, 20, 30, 40, 50, and rear position is pointed to fifth indexing number 5th, and front is 0, and also so here see this we it is also void type function. We declaring here like integer type I, and condition is like if front is equals to rear, it means q is underflow. So in that time here what situation is not front and rear is different. So here q is not situation is not underflow. So simply it's printing like q elements are so we have to using loop for loop, and I equals to front, that means I equals to front is 0, I equals to, that is that it means I equals to 0, and I is less than rear minus 1. So what is our rear is fifth, and 1 minus 1, that is 4. So I equals to 0 and I is less than 4. So it's a start execution, and simply I incremented by, and printing like this, and after rear decremented. So see how it's looking in our console screen. So after printing all the elements, q elements are 10, 20, 30, 40, 50, like that. So see here we implemented all that function inside this program. So see, has starting our header file started, program started from header file, has include stdoi.h, and has include conio.h, and we define the constant value for q, array q, like has defined max is equal to 5. So integer type, we are storing value inside q, that is integer type. So q is having maximum, and front is equals to 0, and rear in the beginning front is also equal to 0, and rear is also equal to 0. So now we are calling simply function void dequeue, void enqueue, and void next void dequeue, void, and void traverse void. So these are all declaration, and we are simply calling this function inside main. Our main, every function is started from our main. So every program is started from main. So here our program is started. So int type choice, ch is nothing but choice. So clear screen function is called, and while loop is here. So it whenever while inside of while loop we are passing like 1, so that's why it's executed unlimited times whenever I do not stop this. So simply I give a message to user, so please for one in queue to enter the element to queue, and two for delete the element of from queue, third for displaying all the element, and fourth one is exist from the program. So simply we printing like enter your choice, what do you want to perform in this. So simply we have to use switch case, switch function. So switch function, we have to pass like our choice. So ch we have to pass, and in case we are calling like enqueue function for inserting that element, and simply print for new line, and traverse function is also called simultaneously. So whatever you entered simultaneously, it is printed to our screen, whatever enter or not. So in case 2, it we simply written calling that function like dequeue. So dequeue function is called here, and printf for new line, and traversing also display function is also called here. And next one, third one is traverse. So say it is simply traverse. So that, because we already used for traversing here, but why we are using traversing in case 3, I will tell you after running that program, this program. So case 4 is exist from this program. So exist is passing 0 value, that means we have to exist from our this program. So switch case having also taking default value. So we simply print a message in default value, like if user having not entered 1 to 4, like user has entered like 0 or greater than 4 value. So in that case it is printing like a statement like invalid key entered. So now our definition part is started from whatever function we are declaring, that function definition part is here. So void enqueue. First, if condition is checked, rear is equal to max, then it simply printed q is overflow. Otherwise, it executed else part. So else part having it's simply did for give taking from any data from user, and that data stores in q rear. So and rear is incremented by 1, and printing that data is added. So in dequeue function, similarly we check the condition if front is equal to rear, then it is underflow. It means this condition is underflow. Otherwise, if condition is not satisfied, then else part is executed, and int I. So simply it is printed like whatever is the front position, or whatever element is the in the front position, that element is deleted. So we simply that percentage d is removed and q front. So here we have to use for loop. So because of we have to shift all that element towards a zeroth location. So after shifting all elements, we have to decrement our rear position. So here decremented, and then we simply defining our traversing function void traverse void int I. Front is, if front is equals to rear, it means q is underflow. else part is executed, and simply it's printing like queue elements are if it is not if condition is not satisfied, then else part is executed, and simply whatever elements are present in queue, that elements are printed there. So see, after compiling, first we have to compile it. So compiling, here 00 showing, so we have to run it. After running this, so first why we are using traverse function. See, when I am calling like third option for traversing, so see, queue is under flow. That means queue having no any element. So once again I want to enter some value, so calling one enqueue function and enter your number 10. I have entered, so it is 10 is added in queue, and queue elements are 10. Once again I have called to enqueue function, so enqueue function is called and 20 is added. I want to store, so here see this 20 is added in queue, and queue elements are 10 and 20. Now once again I have to call a enqueue function. So when I am calling like 1 and I have entered 30, so here queue 30 is added in queue, and queue elements are 10, 20, 30. So now I want to delete 10. So because of zeroth location is 10, so I call dequeue function. So our choice is 2. So simply 10 is removed, and queue elements are 20 and 30. Once again I want to enter some extra element, so once again enqueue function is called, and I want to store 40. So it 40 is inserted. Once again I want to insert so enqueue function is called, and I want to store 10. So 10 is inserted. Once again I call enqueue function. So see, after calling number 50 I have to inserted there. So in our 5 elements are over inserted. So once again I want to call to enqueue function. So see this, what's happened, it's simply giving message queue is overflow, and queue elements are, that means queue is overflow, that means our queue is full. So and it's also showing queue elements are 20, 30, 40, 10, 50. Now I want to perform dequeue operation. So 2 is dequeue is called, and 20 is removed. Once again dequeue is called, and 30 is removed. Once again dequeue is called, and 40 is removed. Once again 10 is called, sorry, dequeue is called, then 10 is removed. Once again dequeue is called, 50 is removed. Once again if you want call in dequeue function, see this what's happened. So here written like queue is under flow. So now I want to enter extra choice, not like 1, 2, 3, 4. So suppose I have entered here 6. Our choice is 6. So simply see this, it's printing like invalid key entered. Its default part is printed here. So I now I exit from this program. So we have to enter 4. So 4 is entered. Then I simply, if you having any question, then please comment in the comment box. And if really this video is helpful to you, then please share with your friends and subscribe my channel. So thank you for watching and listening my presentation. So